Hi all. Let's see, we just have a handful with us so far, so I'll give it a couple minutes. Just getting started here. All right, more people showing up. Let's give it about, I don't know, 3 or 4 minutes. Let people show up here. Getting there, I'll get the chat window open. Just sit tight for a minute. Start at 5 after. We'll start at 11:05. We got 3 more minutes. Get more people on board here. I always make announcements at the beginning of class, and I hate it when people miss the announcements. I don't care if they miss everything else. I don't want to have to repeat stuff though. All right, actually, it looks like we have a good amount of people who have joined us now. Let's see. No, we're still down a lot. Looks like we got 23 on board right now. Let's give it a couple more minutes. While we're waiting, one thing I'm going to request of all of you is that you actually, I know I think I said this earlier, that uh, there would be too much confusion if we had our video on because we'd see too many people. But actually, I've been finding with my other classes it really, really helpful to see faces and see your expressions to know if you all are confused or not, rather than me talking to a blank room. Love the background, Nick. Yeah, feel free to use the custom backgrounds into your preferences menus. I don't care. My wife's been teaching as well online, and she's had students have a silly hat competition, whatever. We could keep this lighthearted. Um, you want to dig out an old Halloween costume, that's all good. But it'd be nice to at least see your faces. So if you keep your microphones off as you've been doing, that way we don't get feedback. But but I'm just going to request you keep your video on. You don't have to, if you've got, family members you're embarrassed about walking around in the background, then it's fine if you keep your video off, or if your room's a mess and you're embarrassed about that. I'm not going to require it. I'm just a request that if you keep your video on, it just helps me. And we're also socially isolated now. I actually think it helps you guys to be able to see each other's faces and realize there's other people out there in the world. Um, so yeah, just a request. Keep your video on, keep your microphone off. At any time, you feel free to turn your microphone on and just yell out a question. Say, hey, I don't understand that, Professor Backman. Again, you can also use the chat window if you want to, if you have a question. I don't always, if I'm focused on whatever presentation I'm giving, I don't always see the chat window. It's up on my screen, but if my eyes are elsewhere, I won't see it immediately, but hopefully eventually I'll see it. You've all been doing Zoom classes for over a week now. There's other features, like there's the raise your hand feature or something. There's other things you can do to get my attention if you need to. But feel free to just, if you have a question, just turn your microphone on and yell out your question. It's fine too. All right, let's get started now. I've stalled enough. It's 11:07. I've stalled too much at this point. So a couple of announcements before we get started on the material. I told you all that last week, Pitzer faculty Thursday afternoon will be considering a vote to make all classes pass-fail. The conversation got muddled. It ended up, our faculty meetings are supposed to be an hour and 15 minutes. It ended up being an over 2-hour faculty meeting. I couldn't stay there till the very end. There was a proposal put forth to make all classes pass-fail. That got voted down when it was, some details of that were realized, and then somebody made an alternate proposal after I left, and that was approved, but I think people are generally unhappy with it. So I think there's going to be further proposals about whether or not to make all our classes pass-fail. And since then, we thought the other colleges were not even considering this, and we've all discovered, at least I've talked to personally faculty at both Pomona and Harvey Mudd, and I know both those campuses are considering this such a move as well. And I suspect CMC and Scripps is also considering it, although I don't have any direct evidence of that. I'll just explain a little bit of the rationale. Oh, somebody in the chat says Scripps student government is now pushing it too. Yeah, I think the students are generally more on board with the faculty. The Pitzer student body voted to go to a universal A system where everybody just, instead of pass-fail, it's like A or fail, which there is some rationale for that. I don't think the faculty considered it so seriously, but some faculty members are on board with that. Another thing that's been proposed is rather than pass-fail, that they come up with a new set of grades that are neither letter grades nor pass-fail, that are something like emergency credit / emergency no credit, something like that. So it's actually marked differently on your transcript. It doesn't just say pass as if every other semester when you took a pass-fail class. So it just signals to anybody looking at your transcript in the future that this was a weird semester, as if they wouldn't already know. We've been continuing our conversations with other graduate schools, with medical schools, with employers, and it looks like everyone across the board is going to know that spring 2020 was a weird semester, and that your transcript may look weird that semester. And to just they're all going to understand that things were going on. I'll just explain a little bit in case you haven't been privy to any of these conversations. There's an equity issue here. Some people don't have a good internet connection. Some people are in vastly different time zones. Some people are in, frankly, abusive households, or households where their parents are just not being so understanding of the situation. Or some people are in a house where there's only one computer being shared by multiple family members. Some people are sharing rooms with siblings. Some people don't even have a house to go to, and there's been a lot of reports of students who are just couch surfing on friends' couches, and it's not clear what kind of access they have or physical environment they have to work in. It's not just a matter of internet access during class, it's a matter of having an environment to get your work done when it's not class time. So it's all these issues that we know students are facing. And some people are perfectly fine. They have their own room, they have their own fast internet connection, their own computer, they have their own time to work, their parents leave them alone. And the idea that we should grade everybody on the same scale, given the variety of access and accommodations students have, it's very, it's very, it's kind of ridiculous to think that everyone should be graded on the scale, same scale, given the different challenges everyone's facing. So I, I, I guess I've been convinced over these conversations that letter grades are not the right way to go. That moving everybody, grading everybody on the same letter grade system, given that everyone's facing different challenges, is just not fair. There's a real equity issue here. People who are at less advantaged backgrounds are having more challenges, and that's just not fair. Even giving students the choice of letter grade versus pass fail isn't fair, because those students who are in more advantaged backgrounds, who are in a very secure environment where they have plenty of time to work, they might have it might be perceived as an advantage to get an A versus someone else who's not in that situation, where the best they can hope for is a pass. So even giving you all the choice of letter grade versus pass fail is perceived as an equity issue. That's a little bit harder to get your head around, but I think there's a real compelling argument that we shouldn't even be giving students the choice there. So um, what Pitzer finally passed, and again, I think this is going to change, is that the default grading option for all Pitzer students is going to move to this emergency credit, no credit. People are uncomfortable with that because people like me teach a lot of mixed classes. So just the Pitzer students in this class have suddenly been moved to something like a pass-fail, but that's only about, I don't know, 15 out of 50 of you or something, I think is the number of Pitzer students I have. So that seems wrong to me, to have a class where some of the students have just been moved to pass-fail, but not everyone. As instructor, I think I was given power to change the grading option for all of you. So I'm going to do that. I'm going to officially move this class to pass-fail for everyone. I'm not going to be so strict as to just not give everyone the choice. The college may do that. I'm just going to warn you, all 5 colleges may move to a situation where you're just not even given the choice. You are going to be on pass-fail and there's nothing you can do about it. That may happen. That has not happened yet. I will consider requests to move to letter grade, but I'm going to be somewhat hesitant about it because, as I say, I am fairly convinced that even giving you that choice is an equity issue. So if you come to me and you say, hey, I want a letter grade because I think I'm going to need an A and that'll help boost my GPA, I'm not going to accept that kind of answer. If you, I don't know what the compelling reasons there might be out there. I don't want to just categorically say there's no situation in which I'll grant a letter grade, because I don't know what kind of stories you each have. I respect there's 50 students in this class and there's 50 different stories. So I will tell you, I'm going to be very hesitant to move students to a letter grade option, but I'll consider it on a case-by-case basis if you think you have a really compelling reason why you should need that. But I want you to also think about your classmates and the fact that when you request a letter grade, you may have a classmate who's not in a position to even be able to make that request. And to understand that if I say no, it's because of me thinking of those students and that there's being an equity issue there. Does that make sense? Is that reasonable? I mean, it may be disappointing to some of you who wanted the A just to get that boost to your GPA if you think that's what you're going to get. But these are weird times, and everybody knows these are weird times. And the thing that we all care about the most is that you learn something in your classes, not that you get an A or a B or C, right? Letter grades should be secondary to the primary consideration, which is just learning, which is really what we're all here for, okay? All right. I appreciate the chat comments too. There's a couple people who have written into the chat some comments about this as I've been talking, and I've been seeing those. And feel free to, keep adding to the chat or to email me privately or whatever, if you have specific thoughts on this you want to share. just so you know, just real quick, I don't want to beat a dead horse about this. This is not just a 5C conversation. This conversation's happening across the country. The most prominent school that's been in the news a lot because they're so prominent is Harvard. You know, they're usually vie for the #1 ranked school in the country, and they moved to some kind of pass-fail system for all their students across the board. And so I think that example has been, that school has been setting an example for a lot of students, a lot of schools across the country. All right. Now, with that said, since I'm moving you all to pass fail, your next question is probably, what do I need to do to pass the class? And I don't have a great answer to that right now. I have to sit and think through exactly what I'm going to pass the class. I'm not going to do an automatic pass, and some people have proposed that because I want to make sure you all learn something, and I think that takes away what little motivation you have to learn anything. The other thing is, every college class to me as a mathematician, you know, I teach a lot of calculus, and a pass in calculus to me tells me you're ready for the next class. I don't want to pass somebody in Calc 1 and then next semester in Calc 2, the instructor says, hey, this student passed Calc 1, you know, but they're clearly not ready for the class. So to me, a pass means you're ready for the next class. So if some class requires CS5, requires that knowledge, I don't want to pass you unless I think you're going to be ready for that class. So that's what I'm going to be thinking about when I look at each of you and decide, do you pass or don't you? Right now, I expect all or almost all of you to pass. So you don't have to stress too much about this. But if you just stop doing any work and don't learn, there's still a lot of stuff we're going to cover. We still have a month of class left. If you don't learn any of that stuff, then I won't be able to pass you. We're not having a second exam, as I've announced before, but we will have a final. I haven't decided what I'm going to do. It may be as simple as, if you pass the final, you pass the class. If you don't pass the final, then I'll look at other stuff and, you know, see, maybe you just blanked on the final, or we're in a bad situation or whatever. So I don't know what I'm going to do, to be honest, but it'll be pretty flexible, I can tell you that, and fairly lenient, but I want to make sure you're ready for the next class if you pass. Is that understandable? Good? All right. I see some head nodding. That's good. Head nodding is all I need. All right. And again, for those of you who joined in late, I'm going to make a request. It's not a requirement. If you're not comfortable with it, that's fine. But I'm going to request that you all keep your video on so I get some kind of visual feedback that you all are understanding things I'm saying. Again, if you don't want to, I'm not going to force you to, and that's fine too. All right. Let's jump back into the material. Let's actually learn some computer science. Unless there's any quick questions about anything I just said, you can chat it. I'll give you a sec. You can turn your mic on and just ask. I'm hearing a lot of silence. Okay. All right. Well, let's move on then. Just real quick, let me just show you where we're at. If I could find the right screen. I'm going to share my screen for a second. I'll just share my desktop here. All right, hopefully you're all seeing. Are you all seeing the course webpage now? Something like that? Yeah, good. Okay, I see some thumbs up. All right. Just want to point out that we are not going in the same order as the other section, as the Harvey Mudd section, or in the same order as that I did things last year. I went through, over spring break, I went through every assignment and every lecture and looked at, correlated them, put them in an order that I felt like made more sense. So I'm going to take a little bit of leeway here with our ordering the material. Today we're going to talk about this concept of a dictionary, very important topic here, and that the assignment, the corresponding assignment that will be due Wednesday night is 10.3. It's technically supposed to be done in week 10. Then we're going to jump back to the stuff from week 9 and then finish the stuff from week 10, and then we'll go in order after that, okay? So we're really kind of jumping around just a little bit. It's really just the stuff we're going to do today is out of order and everything else will be in order. Okay. The dictionary stuff is important. What we'll do after that is we'll get into classes and objects, and those are kind of more advanced concepts, and a dictionary is going to be an example of a class. We've already seen lots of examples of what's called a class. And that'll be nice when we get into classes, that you'll have some kind of prototypical examples in your mind. All right, so let's get into it. Let's see, I've got to play this presentation. Oh shoot, let's see, how's this gonna work? Give me a minute here, because I don't have my iPad with me, which means my technology is set up completely differently, and I actually don't know what I'm doing. So just bear with me for a minute. You should be seeing this, but if I hit play, it's going to disappear. So I think I'm just going to do this. Like this. All right, one more minute, sorry. Still trying to figure out how this is going to work. I don't want to have to do that. Let's see, hold on a sec here. All right, that's fine. All right, well, hopefully you're all seeing like a PowerPoint-like presentation. I don't know what it is you're seeing. Thumbs up, thumbs down. Yep, good, okay, all right. We're going to be talking about dictionaries today, and a lot of what we're going to talk about today is going to lead us into the homework assignment that's going to be due tomorrow night. Again, for most of you, you should get it done before you go to sleep tomorrow night, but you do have till 8 a.m. or 9 a.m. Thursday morning, either 8 or 9 a.m. Thursday morning to get it done. I have not enabled Gradescope to accept this submission yet, but I will right after this class. I'll enable Gradescope, so if you want to just get started on it, you can submit at any time. And again, I pushed back the deadline. Instead of being doing midnight tomorrow night, I pushed it back to 8 or 9 a.m. Thursday morning to allow for the people in vastly different time zones to have a chance, the same opportunities to finish it. All right, what we're going to talk about today is this idea of a dictionary. So we've already seen lots of data types within Python. So we've seen strings, and we've seen various numerical data types like floats and ints. And then we've also seen lists, lists and strings we've seen almost from the very first day of the class. And there's a similar kind of data type to a list called the dictionary, and it's just as important. And I would say it's almost as important, very commonly used, and super useful in applications. The basic question we're going to ask that's going to motivate the homework problem that you're going to do, problem 10.3, is how would you write a computer program to write text? Let's say you want to be snarky and some professor asks you to write an essay. How could you write a computer program to write that essay for you? And actually, I think the result of homework 10.3 is to write a 500-word essay, but you're not really going to write it. You're going to write a program to write it. So that's the basic question we're going to ask. And a related question is what's on the slide here, is if somebody else wrote a program to generate an essay, how could you tell? How can you look at that and say, hey, that's not human generated, that's computer generated? And that can be surprisingly difficult. And I'll just interject something that's not on any of these slides. This is a rapidly changing area of computer science, and extremely important. There's a whole topic called natural language processing. You could take classes in natural language processing. The woman teaching CS5 right now at Harvey Mudd, Julie Madero, this is her specialty. She teaches a class in natural language processing. next year in the spring, for those of you who will still be around, I will probably teach a class in machine learning and deep learning. And in that class, we'll use some neural networks to do some advanced natural language processing. I taught a class like that last year, and I fed it all the Led Zeppelin lyrics and had it generate a Led Zeppelin song, and it was shockingly like accurate if you are familiar with that. Um, so it can be pretty fun. We're going to do a much more naive text generation model today, and in your homework, called a Markov model. And even though it's about the most naive thing you can think of doing, it's still shockingly good. I mean, some of the results that we'll see are still pretty accurate. And now, I'm sorry, give me one sec. I've lost the chat window, so I don't know if people are saying things. Oh, somebody did say something. Can we actually take those classes as non-majors? Yes, I will. It's actually, that class on machine learning is going to be considered an upper level CS elective. The only CS background, though, I will require is a class in Python. It'll help to have had a class in data science as well, because it's also going to be considered a data science program. I don't know if I've said this before. It's worth repeating. At least 4 of the 5 classes are independently developing data science programs, for which this class is an important prerequisite. So even if you're not a CS major, none of you should be CS majors, you might want to think about at least a data science minor. CMC has had a data science minor. They were the first one to do it. They have a data science minor on the books now for, I think, a year or two. They just had their major approved. So if you're a CMC student, you could do the data science major at CMC. Scripps, as of I think just a week ago, got their data science minor approved. Pitzer has a data science minor proposal that has been submitted to the college, and it's going through its various committees. And I don't know if it'll be online for next year. At least the year after, it'll be online. Maybe next year, we're going to be optimistic. I know if you're a Pitzer student and Pitzer doesn't offer a major, then some other campus does, then you can do the other campus's major. So if you're a Pitzer student, since CMC has a data science major online, you can major in data science now if you do it through CMC. But you'd have to get a CMC faculty member willing to advise you. And if the major becomes in really high demand, that's going to be more and more of a challenge. Sorry, I'm babbling now. This is all a digression, but I know a lot of people are thinking about data science, so it was worth talking about.
Did you say you're teaching the machine learning in spring?
Sorry, say that again, Nick?
Are you teaching machine learning in spring?
Yeah, it'll be in the spring, a year from now.
And then are you doing intro to data science in the fall or something?
I'm not, no. I'd like to, but I just don't have room in my schedule. Yeah.
Do you know who is?
That's a great question. Intro to data science, I think it's going to be consistently offered at CMC, hopefully every semester. And I think Scripps is now making a commitment to offer it at least once a year, if not every semester. And my guess is they will teach it in the fall, but I'm not sure. So okay. I would look at Scripps and CMC. For Pitzer's data science minor, we're going to require intro CS and an intro data science class. But that intro data science class could be the Scripps class, the CMC class, or CS35 at MUD. So that's another one you could take. It's not called intro data science, but CS35 at MUD is actually, you do a lot of the same stuff you would do in an intro data science class.
What's that class called?
CS35 at MUD. I don't know, to be honest. Sorry.
Okay, no problem.
And I think that might only be offered in the spring, but I'm not sure. So anyway, if you're thinking about classes to go into after this one that might use this class, I would look at those kinds of classes. It's going to be hard for any of you to get into CS60, CS70. That's the kind of the CS track for CS majors. But these data science classes and CS35, those are CS class, follow-up CS classes for non-majors. I would definitely look at those. Since I'm talking about it and babbling here, this data science class at CMC is taught in R. which is fine. Their intro CS class is taught in Python, and then they move their students into R because their feeling is that any budding data science should know both Python and R. So they want you to have both. Scripps has a different attitude. Scripps' data science class is in Python, and they want to just build on the Python you already know, which is fine too. Same with CS35 at MUD, that's also in Python. So there's advantages and disadvantages to forcing you to learn another language. It's good to know more than one language, so you might want that R class at CMC. It's also good to keep deepening your Python knowledge. So you can go either way, but these are definitely follow-up classes that you should think of, that you should all be thinking about. All right, sorry, I've gotten as far as slide 2 in our little presentation here, so let's just keep going. This is the question we're going to be thinking about is how do you write a computer program not just to generate text, but to generate text in the style of a particular author? That's even more of a challenge. How do I generate text that looks like Shakespearean text? Or how do I generate text, or how do you as a student create a computer program that generates text that looks like your particular writing, that mimics not just human writing, but your particular writing is an even further challenge. And we're going to see like there's some very naive algorithms to do this that we're going to look at, that you're going to code this up. Here's a little tiny snippet of sample text here. I like Pop-Tarts and 42 and Spam, etc. Just looking at this, whoever wrote this, you might ask, what's the most likely first word if we were to try to mimic this writing style? And it looks to me like there's 3 sentences here. 2 of those 3 sentences start with the word I. So you might think if you're generating random text, then maybe 2/3 of the time your random text should start, each sentence of your random text should start with the sentence I, with the word I. So it's that kind of algorithm we're going to be looking at, where we'll try to analyze the probability of each word appearing in each place in the sentence, and then generate new words according to those probabilities. So again, we're going to be using some probability here. We've seen probability generated things. You just had a probability algorithm to estimate pi. We did some probabilities earlier in the semester, and these were all called Markov processes. So this is called a Markov model to generate text, a Markov text generation model. Here are some examples. So each of these paragraphs was generated by a computer program, but it was a computer program that was specifically written to mimic the style of a particular author. And the way that worked was they uploaded a writing sample from that author and then asked the program to generate an essay based on that writing sample. So anybody make any guesses here? There's a little hint there. You have to identify the author of each piece. That first one, there's a telltale word right in the middle of the paragraph. Hint, they're all British. I don't know the answer to all 4 of these. Up at the top left one. I see some smiles. I think people are seeing the word right in the center of that top left paragraph. You can just put it in the text box, the chat box. Yeah, good. Kaya's got it. Yeah, there's the name Hagrid in there. It's clearly Hagrid was a character from Harry Potter. And so that was trained on some writings from J.K. Rowling. I think the bottom left one is fairly obvious. Especially if you look at the hint that they're all British authors, there's a lot of O's and thous and thises and thys in the bottom left one. That was clearly trained on Shakespeare. The one on the bottom right, I'm gonna guess the U.S. Constitution, but it says hint they're all British. I don't know. Was Thomas Jefferson British? Maybe he was. Was he born in England? I'm not sure. I have no idea what the top right one was. Anybody have any guesses? Anybody want to venture a guess for the authors of either the top right paragraph or the bottom right paragraph? think it's a mishmash of One Direction for the top right, could be. Yeah, sounds like it. Okay, all right, well, let's move on. Let's see. All right, so again, this is what we're going to do is specifically called a first order Markov model. And in a first order Markov model, each word is just generated by looking at the previous word. So you look back one word to generate the next word. That's why it's first order. A second order Markov model, we look back two words. We take the last two words into consideration to generate the next word. Okay, so we're writing really stupid models. All it's going to do is look at a word and say, well, based on the text sample I have, what's the most likely next word? And maybe there'll be 5 different choices, and then we can look at even the frequency with which each choice happens and then picks another word based on those frequencies. To do this, again, this whole assignment is really to introduce you to this new data structure. We've already seen lists, and lists are called sequential containers. So it's a bunch of data, and they happen in sequence. You know what the 0th element of the list is. You know what the first element is. You know what the second element is. The data structure we're going to need is called a dictionary. And in a dictionary, elements of the dictionary don't happen in any particular order. So the values in the dictionary here at the bottom of the screen are 2 and 1. And the keys help you reference those values. So rather than referencing in a list, you reference a value by saying its index. If I want to reference the number 5 in that list at the top of the screen, then I say, oh, that's the index 1 element. Okay, so the index, which is 1, references the value, which is 5 at the top of the screen there. And the dictionary, if I want to reference the value 1, then I do that by giving, instead of the index, I give the key. So if I say I have a dictionary, what is the value that corresponds to the key of 42? Well, that would give me 1. Okay, so I don't have my iPad with me, so I can't write on the screen and emphasize this, but I'm trying to use a lot of language here in my words. So if I confuse you, just let me know. Dictionaries are arbitrary containers, which means any data type can serve as a key and any data type can serve as a value. So in this dictionary, the keys are strings and the values are integers. So if I want to reference the value 1999, I do that by using the key, which is the string rabbit, okay? And I think probably many of you, I hope some of you are guessing this particular dictionary is 2 members of the Chinese zodiac. Right? So you can write down the full Chinese zodiac, which would have 12 key value pairs, which means there'd be 12 keys corresponding to 12 different values. One thing I want to point out about dictionaries, going back a couple of slides, lists, you indicate to Python when you're typing a list by putting those square brackets around the whole list. You indicate to Python a dictionary by putting the curly brackets around the whole dictionary. And then each element of that dictionary is a pair of things separated by a colon. You have key, colon, val, comma, key, colon, value. And then when you want to end the dictionary, you end it with that curly bracket. So make sure you're understanding that syntax at the bottom of the screen there. It's a little more complicated than the list syntax where you're just separating the things by commas. In a dictionary, where we have pairs of things we're separating by commas. Okay. And again, in a dictionary, dictionaries are arbitrary containers, which means you could put anything you want in a dictionary. So in this example of a dictionary, the keys are strings and the values are lists. So if you ask for Z of ox, in other words, if I typed Z here, it's driving me crazy. Let's see, maybe I can, hold on. I guess I could. Yeah, if I were to ask for Z of ox. That's the syntax here. And I just hit enter. What would happen is I would get the result from Python, which is the list 1997, 1985, comma, etc. Right? It would just give me that full list. Right. So once you enter the dictionary, the Z dictionary, once you enter that dictionary, then you reference the value of that dictionary for a given key the same way you did that for lists. So for lists, if Z were the name of a list, then what you'd put in the brackets is the index. Here Z is a dictionary, so what you put in the brackets is a key. And what you get out is the value that corresponds to that key. And in this case, that's a list. So here the keys are strings, right? Ox is a string. And the value that corresponds to that key is a list of years. Okay, so key value pairs. So, you could debate whether or not this should be considered a pair. It looks like it's multiple objects, but it's really just two objects. You have a string as one element, and then a pair is the other element. Okay.
I got a question on that.
Yeah.
So if this were to like keep repeating, like 1997, 85, 73, would you have to like write out all those numbers in the Python code?
Yeah, all data in Python is finite, right? So you're only going to type a finite number of years in here.
Okay.
There's no way to write an infinite list. Yeah. This the dot that's there, that's not something you type into Python. The dot that's there means somebody wrote this slide and got tired of typing years in.
I get it.
Don't take that dot literally.
You wouldn't use the curly brackets for the ox?
The curly brackets are at the beginning of the dictionary. Do you see I'm highlighting that? I don't know what you see and what you don't see. And at the end of the dictionary.
Yeah, but so when we type Z ox, it's in brackets.
Oh yeah, down here, yeah. Right, just like if you have a list, let's see, stop that. Here, let me. Yeah, if I had a list, L, then I would reference a particular element of that list by putting just a number in square brackets, right? Okay. And I'd get out whatever the value of L of 2 is. I don't know, maybe it's 42, right? So when you have a list, you reference a value in the list by putting its index in square brackets. When you have a dictionary, you reference a value of that dictionary, which in that case is a whole list, by putting the key for that value in square brackets. Okay? So keys for dictionary are taking the place of indices for lists. Does that make more sense?
Yeah.
Yeah, it's a lot to get used to, actually. I remember being really confused by dictionaries the first time I saw them. Just like in lists, we can ask if you have a particular element of a list. That's asking about by using the if statement, you could say if 5 in L, and that'll give you either true or false, depending on if 5 is a value in L. Dictionaries work a little bit differently, because if you use the if value, it's going to ask you whether or not that key is in the dictionary. So if you say if dragon in Z, and in this case, you're going to get true, because dragon is one of the keys in the dictionary Z. Okay. If you want to ask about a particular year, you can do what's on the next line there. You can say, is 1969 one of the years for dragon in this dictionary? And that'll either be true or false. And I don't know the answer. Is 1969 a dragon? No, 1969 is the year I was born. That was a rooster. Okay, so that would return false. All right, so we're going to build dictionaries. In fact, we're going to build dictionaries by an automated process. We're going to actually create a dictionary. We're going to write a program to create a dictionary. And the way that program is going to work is it's going to read a bunch of text and then create a dictionary based on that text. Okay, we're going to do an automatic dictionary creation. So LOW at the top of the screen stands for list of words. So that's going to be our starting point. We're going to start with a list of words. Okay, and we're going to develop write a little program here. It's already written. There's a program here that is going to create a dictionary for us. So let's think about what happens when we run this. First, D starts out, just like you have an empty list by going square bracket, you can have an empty dictionary by going curly bracket, curly bracket. Right? So D starts out being just an empty dictionary. There's nothing in the dictionary D. All right, and then we jump into this for loop. For W in L, okay? In other words, W is going to sequentially take on each element of the list of words. So the first thing W is going to be is spam, right? So W is going to start out being spam. And then we're going to check, is W a key in our dictionary D? Well, right now our dictionary D is empty. So W is not there. So since it's not there, we go, if W is not in D. So that's true. W is not in D. W is not a key in our dictionary D because our dictionary D is empty. There are no keys, right? So what's going to do is it's going to say, all right, let's add to our dictionary D, and we're going to add a key value pair. The key is going to be W, and the value will be 1. Right? So after this first line runs, then what we'll see, let's see if I could do this. There we go. After this first line runs, then D will be curly bracket. There'll be the key spam, and that'll correspond to the value 1. Right? So that for loop has just run one time so far. We looked at that first letter, that first word spam. Spam was not in our dictionary because our dictionary was empty. So we added to our dictionary, and what we're adding is a key value pair. The value is 1, and that's going to correspond to the key of W. This is just like when you have a list. You can add to a list by saying L of 2 equals 7. So that would assign 7 to the index 2 element in your list. Now we're assigning the value 1 to the key W in our dictionary. Okay. All right, that's the first time through this for loop. The second time through this for loop, W is spam again. Now it's the second spam. So now we look at we jump to this if statement. We say if W not in D, but W is in D, right? Because D is over here. Spam is in our dictionary. So now we go to the else part, and the else part says, well, in this case, take the value associated to the key spam and add 1 to it. That plus equal 1 will add 1 to that value. So all we end up with after the second one is 2. We've added 1 to the value corresponding to the key spam. Okay. Then we go through the for loop again. The next time through the for loop, W is Pop-Tarts. Okay. Pop-Tarts is not in our dictionary so far. So we're in this part of the for loop. And that says add Pop-Tarts as a new key, and the value for that key should be 1. So at this point, our dictionary will be there's the quote. All right, and then last time through, we see spam again. Spam is in our dictionary, so we're going to jump down to the else statement and add 1 to the value that corresponds to the key spam. And that's how we end up with this last line. All right, now notice something down there. I wrote spam :2, comma, Pop-Tarts :1. And whoever wrote this slide wrote the next line as Pop-Tarts first and then spam. Okay. The fact that the order there was switched doesn't matter. In a dictionary, key value pairs don't have an order to them. They're not sequential containers. Lists are sequential, dictionaries are not. So you can write those pairs in any order you want, and it'll be the same dictionary. So if I wrote Pop-Tarts 1, spam, comma, spam 3, and somebody else wrote spam 3, comma, Pop-Tarts 1, that's the same dictionary. It's the same values for each key. And so that's something that is a little bit hard for people to get their head around after they've working with lists for so long. The fact that you can rearrange the pairs in a dictionary is something new to get used to. Okay. All right. So what this does, what does this program do? This program creates a dictionary, and what is the result of that dictionary? What does that dictionary have to do with the list of words we were given at the beginning? Anybody want to put it in the chat window?
It just tells you how frequent every word's used, right?
Good, Celine. That's right. Pop-Tarts, so it's just telling us in the original list of words, the word spam occurred 3 times and the word Pop-Tarts occurred once. Right? It's just counting how many times each word works. Another way, Celine used the word frequency, right? So it is telling us the frequency 3/4 of the time. If you divide, you see the word spam, and 1/4 of the time you see the word Pop-Tarts. All right, now the words we're going to get are going to come from reading some text from a file. So for example, if I want to read in all the words of Shakespeare, then that's going to be stored in some file on our computers. And then we're going to have to read that file in and then do this counting process where we build the dictionary which counts all the words in there. So you got to know a little bit more, some new things. I think we've done some similar kinds of things in this class where we've opened and closed files. Maybe when we were doing the Mandelbrot or something, we opened a picture file and closed a picture file. Can't remember. This is the syntax for it. Open a.text. All that does is it opens the file. Now, opening a file is not the same thing as reading a file. Opening a file just means that F, after this first line runs, F points to a place on your computer where the file is located. Okay, it's like you've opened a door, but you haven't walked into the room yet. Right? You should think of the word open as literally that. You've opened the door to this file, but you haven't done anything with it yet. You haven't even read that file into Python. Okay, the next line is what now imports the file that we've opened into Python. It's that read file. So now we have the door to the text has been opened, and now we're going to read that text in and store it into the name text. So the word text after the second line runs will now be one giant string representing the entire text. So if these are all the words of Shakespeare, all the words of Shakespeare are now stored in this one variable called text, right? And Python can handle that much data. You can I think on one of the slides in a minute, it's going to say Shakespeare wrote something like 880,000 words. You can have one variable representing a string that's 880,000 words long, okay? This next line, it says is optional, but it's really good practice. Whenever you open a door, you should close it behind you. So when you're done reading a file, it's good practice to close that file. And in some languages, in Python, it won't matter so much. In some languages, this is really essential. So it's a good habit to get into. Whenever you open something, do something with it, you should then close it. At this point, the word text is going to represent all the words, right? So if this is all the words of Shakespeare, they're going to be one giant string. To break that up into a list of words, rather than just one long string, there is a split command. If you do text.split, it'll take this long list and turn it into this long string and turn it into a list of individual words. Okay, so there's some new Python commands on this page. Open opens a file, read reads that file in, closes the file, and then split takes a string and splits it up into a list of words. All right, so if we combine that, here's a quick thing you can do just to do a quick test. You can open any file like all the words of Shakespeare, read it into text, split it into a list of words. So this is all just what's on the previous slide. And then you can use the length function to say how many words there were in that file. So if I want to know how many words Shakespeare wrote, you can download all the words of Shakespeare, all the text of everything Shakespeare ever wrote. You can download that from the internet. There's lots of sites that have that. And you can run this little program, and what it'll print out is how many words are in that file. Yeah, here it is. Shakespeare used 884,647 words, but there were only 31,534 different words in all the writings of Shakespeare. So you get a sense of how many repetitions there were, and that's typical, right? We use typical book uses just a few different words, a few thousand different words. Shakespeare is famous for having made up a lot of words, and it may not, some of you may not know that a lot of the common words in the English language were just made up by Shakespeare. I think they're not on here, but the words that I remember are, I think, upstairs and downstairs, really common English words. I think those were invented by Shakespeare. I think the words on the slide are a little bit less common, but certainly you see these words too. Anybody know the answer to the one on the right? There's one word in the Oxford English Dictionary that was written by an author who is alive right now. Anybody know what it is and who the author is? A little trivia question for you. What's the only word in the Oxford English Dictionary written by a living author who is alive right now? It's again our friend J.K. Rowling, and it's apparently the word muggle. Shows the influence of Harry Potter on our modern society. All right, this again, we're just now combining. So up here at the top of the screen, you see that program we had before, opens a file, reads it in, closes the file, and then prints out how many words there were. Now we're going to combine that with the program we wrote before to build a dictionary. And that dictionary will have all of the keys in that dictionary will be the unique words in the original file, and the values are just counting how many times that word appeared. So if this is Shakespeare, one of the keys will be the word thou, T-H-O-U, Shakespeare used a lot, and then the value associated with that key will be just the number of times the word thou appeared in all the writings of Shakespeare. Okay? And if you want to know how many distinct words there were, you can still use the length function on a dictionary. And the length function in this case tells you how many key value pairs there are. Now, that's the same thing as just counting the number of keys, which will be the number of distinct words in that dictionary. So if you want to know how many words that Shakespeare wrote, if you want to know where these numbers come from, you can run that little program yourself and import all the words of Shakespeare and then build that dictionary and then ask how many keys are there in the dictionary. Presumably you'll get 31,534. All right, so yeah, Nick.
What is the \n?
\n is new line. So when you print out \n, it just goes to the next line.
Okay.
Yeah. All right, now what we want to do is we want to not just read in a text file and say how many key value pairs there are, but we want to use that dictionary or something like that dictionary to generate new text, right? So remember, our goal was not just to do some analysis of all the writings of Shakespeare. We want to create some new writings that are Shakespearean in flavor. They kind of look like the words of Shakespeare. So we're going to do something very similar.
So sorry.
We're going to do something very similar. And here's an example where we read in this original file up here, I like Pop-Tarts and 42 and Spam, et cetera, et cetera, et cetera. And then what gets generated is something that kind of sounds like that, and but is really nonsensical. I mean, the original sentence here was kind of nonsensical. There's some better examples that we'll see. The way we're going to do this is we're going to analyze, we're going to do something a lot like what we did before, where we're going to read in the text file, that's the top of the screen here. We're going to read in this text file, and instead of counting each word, we're going to create a dictionary where each word is still a key, but the value we're going to associate that with key is a list of all the next words. So for instance, up there at the top, the word I appears 3 times. The next word after it is like, is like in the first instance. The second time the next word I appears, the word I appears, the next word is get. And the last time the word I appears, the next word is like, right? So the keys here are the words in the text, and the values are the list of all of the next words. What about here? What about this word like? What's the next word after like? What's the first time like appears? What's the next word?
Pop-Tarts.
Good, Pop-Tarts. Okay, and the next time like appears, what's the next word? I think it just appears one more time.
Spam.
Spam. Good. All right, does everybody see the dictionary we're generating? So rather than counting the occurrences of each word, we're going to keep track of a list of all of the next words. And then we're going to use this dictionary to create a generative model where we generate text instead of just counting text. There's one special thing on here, which is the $sign. What do you think that $sign represents? The thing associated to the $sign is I, will, and I. Where are those in the original text?
Does it represent the beginning of a sentence?
Good, yes. We want to know what to start each sentence with. So we're going to use $sign just to represent the beginning of a sentence. And then the list associated with $sign, the value associated with the key $sign is going to be just all the first words of all the sentences. All right, this program that you see will generate that dictionary. So this is how that dictionary we were just looking at is created. And this program looks a whole lot like the counting program that we saw a minute ago. It's almost exactly the same. We have a for loop that loops through the list of words. Then we go right into an if statement. And if the word that we're looking at is not in the dictionary, then we're going to add it to the dictionary. And if the word is in the dictionary, what we're going to add is the next word, right? We have that plus equal, right? So if you remember that code we had up a few minutes ago, let's see where I'm on slide 25. Let's just bump back to that, right? This code that's here on the left looks very, very similar to the code we're about to analyze, okay? So again, we're going to start out with D being the empty dictionary. And we're going to start out with PW. PW stands for present word. It's the word we're looking at right now. If the present word is $sign, that means we're looking at the beginning of the sentence, okay? NW is going to stand for next word. So for next word in list of W, so next word is going to start out being the first word in the list, which will be I, okay? And we're going to say, is the present word in our dictionary? If it's not, we'll add it to the dictionary and we'll start a list, and the value in that list is going to be the next word, the word after that. If the present word is in our dictionary, then we're going to add to its associated list the next word. And that plus equal just adds another element onto the list, which is the next word. And then when we're done with that, what do we want to put here? What should the present word be? Once we've looked at a particular word, then somehow we want to advance forward. So we're already done looking at the present word. So what, in the next word, so what should the present word become? Any guesses here? How do we advance forward?
Does the present word become the next word or something?
Perfect. Yep. Yep. Once we finish looking at the next word, then that next word becomes the present word. And then we look at the next word. Okay. That's exactly right. We just sort of loop through this, right? And that's, so this is that program we just looked at. We start out with the previous word being just $sign. So we're just start out at the beginning of a sentence. And then every time we look at the next word, we're going to add it in to the dictionary somewhere, either as a new dictionary element, or we're going to add it to the list corresponding to some existing dictionary element, right? And then the last thing you have to do is change, once you're done with that next word, you have to make it the new present word and move on to the next word by you keep going through your for loop, right? One thing we didn't do, the one thing this code doesn't do is it doesn't worry about punctuation. So this is what's generated at the bottom. If you the list of words is what's at the top of the screen here, then what gets generated at the bottom is this dictionary we see here. And we're seeing the word spam with a period. That's a little bit bad because spam with a period is a different string than spam without a period. So we haven't said how to do it here, but you may want to add another conditional, another if statement to detect whether or not you have some punctuation there, and maybe remove that punctuation if you have it. So the way you might do that is you look at each string, look at the last character in the string. So let's say if S is a string, you can look at S of -1. That's the last character. And you can say, if S of -1 equals period or exclamation point or comma, etc., then just replace that string with everything up to the last character. So that would remove that punctuation point. So that's just something for you to think about. I know I said that fairly quickly because I'm starting to run low on time here. How you would remove punctuation. The second part of that, so that's the model, the Markov model is that dictionary that this previous slide, we've created this dictionary. Then now to generate new text, we're going to look through this Markov model, this dictionary. Every time we generate a word, we want to know what's the next word going to be. So we'll look at the list associated to that and pick one word at random from that list for the next word. Then it'll become the present word. We'll look at its associated list, pick one word at random from that list, and then that'll become the next word. Then we'll look at its associated list, pick one word at random from that word, from that list, and then it becomes the present word. Right? So we're going to kind of march through, always picking one word at random from the list associated with the previous word, and that'll create this new text. This is exactly what you're going to do in your homework assignment. So I'm not going to give you too much detail about how to do it here, but this is a very, very common and naive way to generate text. You can see some spam. These are just examples of email generated spam. I can skip most of this. This is a interesting example. This made the news a couple of years ago. So what this was, some really snarky scientist responded to a solicitation for conference papers. So with big academic conferences, they often ask academics to submit a paper to the conference, and if your paper is accepted, you can come present the paper in person at this conference. So what this person did was they downloaded all of the papers that were published in that journal, and then they used that to create a third order Markov model. So each word was generated by looking at the 3 previous words. And this paper is just gibberish, but it kind of looks like it's reasonable. It looks like it's English. And then this paper turned out to be accepted for publication, which was an indication that this conference was just complete bogus. There's a lot of like scam conferences out there. And they even like put in a little, says a little hint that this was a Markov model to see if anybody would see that. Here's a little joke. It's a third order Markov wardrobe. So I think the point here is that we do these Markov processes all the time when we do daily tasks. When you're cooking, when you're getting dressed, you know, you might put on your clothes in a particular order, and based on the clothing item that you just put on, that might inform your next choice, right? If you're trying to build a coordinated outfit, if you care about color coordination or fashion coordination, once you've picked your pants, that might inform the choice of shirt that you would pick or something like that, or your socks, depending on how these things are. You know, cooking is the same sort of way. Once, if you're cooking a meal and you're not following a recipe, you know, you've picked a certain set of ingredients that might inform what spices you pick afterwards, that sort of thing. Here's another example. This is an even more naive version where somebody generated a scientific paper that was accepted to a conference just by hitting the autocomplete button on their iPhone. They just started with the word atomic and then kept hitting the autocomplete button. And this is another example of a bogus conference that accepted this paper. You're going to do this by generating, this is a good one to look at. Let's see if I still have it up. Just give me a sec here. Oh yeah, here it is. Let's see. Hopefully you can all, oh no, let's see. Stop. Sorry, you're seeing all kinds of stuff at this point, I'm sure. Can you all see this web page?
Today I would like to show you how to write
Can you hear
a
that?
scientific paper about atomic physics. So you just type in atomic and then you just use the power of iOS auto-completion. And with this, you can very quickly write a paper. And let's say we use nuclear and autocomplete. Right, repeat this as often as you want, and you get a paper that can easily be accepted at a scientific conference. Good luck. Today I would like to show you how to write.
Not all scientific conferences are bogus. I can assure you of that. But there are some scam conferences out there. And every scientist has this experience. I get these solicitations almost daily from conferences that what happens is they want you to submit your paper, and then they'll accept you and they'll say, if you want to come to our conference, there's a $2,000 registration fee that you have to pay to come to this international world conference. And of course, they're just trying to get your money from that. So it's just a scam, and most scientists know that. And it's fairly easy to get a paper accepted to one of these things because really they just want your money. So it's kind of funny and also kind of sad. All right. Are there any questions? We're all done. You're going to experiment this with tomorrow. Just a quick reminder, I've said it many times now, but if anybody who's been missing class, my office hours have shifted to 9 to 10:30 Monday, Wednesday. So I will have office hours tomorrow at 9 if you want to get started on this. You should try to get started on this tomorrow. Don't leave it all for tomorrow afternoon to do the whole project. It's just one homework assignment, but it'll take you some time, a lot of the necessary time to do it. Try to start it today. Come ask me questions tomorrow in office hours. I've split in my lab time to Mondays and Wednesdays, so I'm only doing an hour Wednesday afternoon for lab. So I'll be online 1:15 to 2:15 tomorrow afternoon, as well as my office hours in the morning. If you have more questions, I can help you through it. Let me ask you this before I let you all go. Have the Grooters been in touch with you all? They were thinking about some volunteer hours. And I've noticed Harris just likes to communicate with you all directly and hasn't been telling me stuff, but I don't know if he's done that. No? Okay. Or I'll follow up with them, see if they were, I don't know where they're at in terms of their own schoolwork. They were thinking they might want to do some volunteer hours, but then they were going to get back to me with whether or not they felt they had the time to do that. So I'll just follow up with a quick email saying what their thoughts have been on that, if that's changed. All right. Good luck. I'll see you all tomorrow if you show up in lab. Bye.